All right, it's time for the semester one review. What we're going to do now is I'm going to go through all the problems and explain each of the answers. So you can go through and fast forward the video or rewind it as you need. If you need to skip ahead to a problem that you need help with, go ahead and do that. The idea is that you've gone through the review, gone through all the questions that you can, and then use the time now to watch the video and have explanations for any of the problems that you need explained. So keep in mind we have algebra and accelerated algebra in the same video. Keep in mind that after question 50, that is the end of algebra 1, and from 51 on through to 57, that will be the extra portion for the accelerated algebra. So if you're not accelerated, you can stop it after question 50. So we'll get started going through all the problems. Like I said, feel free to skip ahead if you need to. So write each problem as an algebraic expression. 2 cubed, we know 2 is the base, 3 is the exponent. Q increased by 12 is equal to 50. So my clue word here is increased by. That means I'm adding, and equal to. So Q increased by 12 is equal to 50. Should look like that. So our next one here, n to the 7th is greater than or equal to 12. So n is my base, 7 is my exponent, greater or equal to, then we got 12 there. And hopefully that is correct. Yes, it is. Next one we got order of operations. So we're trying to figure out which one to do first. So I've got parentheses. Remember, we always do parentheses first, then exponents, then multiply, divide, left to right, and then add or subtract, left to right. So in this case, we have two sets of parentheses. So we'll take the first one on the left. 15 times 2 is 30. So 1 plus 30. And then we've also got this set of parentheses, so I'll do that one as well. Divided by 4 plus 2 is 6. So now I've got addition and division. I do multiply, divide before add, subtract. So I've got 1 plus 5. 1 plus 5 is 6. Okay, next problem. Here we have parentheses. So 3 plus 5 is 8. So I have 3 plus 6 times 3 minus 8. And next we have add, multiply, subtract. So I do multiply next. 3 plus 18 minus 8. Next we do add or subtract left to right. So I have add and subtract left over, so I go order from left to right. So I'm going to add first, and then I'll subtract. 21 minus 8 is 13. Okay. Next, we're solving equations, solving for v. So I got to get v all alone. I see v is being multiplied by negative 20. So how do I undo that? The inverse operation is divide both sides by negative 20. When I divide this side, I'm left with 1v, or just v. 120 divided by negative 20 is negative 6. Okay. Next equation, I've got negative 8 plus x divided by 3 equals negative 2. So I gotta get the x all alone. First operation is adding a negative 3, and then dividing by 3. So reverse the order, so times 3 on both sides. So I get negative 8 plus x equals negative 6. And then I add 8, it's the opposite of negative 8. X equals positive 2. Okay. Next question. Solving for k. So k, I add a negative 2, and then I divide by 3. So same thing, I'm going to multiply both sides by 3. 12 equals negative 2 plus k. Next, I need to add 2 to both sides to get rid of the negative 2. I'm left with k equals 14, or 14 equals k. Next one, here, I have x minus 2 minus 4. I can combine these like terms together and get x minus 6 equals negative 10. And then to get x alone, I can add 6 to both sides. So I can get x equal to negative 4. Our next problem, we're solving for x again. I've got parentheses, so one way I can get rid of parentheses is I can distribute to get negative 30. And negative 5 times positive 6 is negative 30x. Big thing there is watch your negatives. This is a negative 5. This is a positive 6. And that equals 150. So now to get x all alone, I can add 30 to both sides to get the x's alone on one side. So I have negative 30x equals 180. Multiply or divide, the answer you'll find. So we need to divide by negative 30 to get x alone. And that will leave us with x equals negative 6. Alright, now we've got x's on both sides of the equation. It looks like it might be a little more difficult, but we just follow the same principles we've been using. So I need to combine like terms. Anytime I see parentheses, I can distribute those. So I have negative 2x. Positive 5 times 3x is positive 15x. And a positive 5 times a positive 3 is positive 15. And on the right side of the equation, we can't combine those terms, so we'll leave negative 34 plus 6x. Okay, next step after I've distributed, I need to combine like terms. So I can combine negative 2x and positive 15x to get 13x. And I got positive 15 equals negative 34 plus 6x. Next, I need to get x terms alone on one side. So I'm going to subtract 6x to get the x's on the left side of the equation. Keep in mind there's more than one way to solve an equation, so maybe you did it a different way. This is just one of the ways that I'm showing. And I have negative 34 left on the right side of the equation. Next, I need to get the x terms alone, so I need to eliminate the positive 15, so I subtract 15 from both sides. That'll leave me with 7x equal to negative 49. And then x is multiplied by 7, so I divide 7. And that'll give me x equal to negative 7. Check the answer. Correct. All right, moving on. Next question. Here we have an absolute value equation. So remember, we need to get absolute value alone because the absolute value is equal to 2. So what that means on our number line, I know what's 2 away from 0. Well, it's either 2 or negative 2. So I know my solution inside that absolute value will either be negative 2 or 2. So I just make my two equations now. N divided by 2 has to equal either negative 2 or n divided by 10 has to equal positive 2. Okay? So anytime we have absolute value, we got to break it into those two different equations because absolute value is a distance from 0. We can be the positive or the negative. We just solve both of those. Multiply both sides by 10. N equals negative 20. Multiply both sides by 10. N equals positive 20. So we've got two solutions here. N equals negative 20 or positive 20. Okay, now we can't distribute inside the absolute value brackets. So we need to get absolute value all alone first. So what I need to do is eliminate this negative 8 that's being multiplied by the absolute value of m plus 10. So I'm going to divide both sides by negative 10 first of all, which is good because this will give us absolute value of m plus 10 equals a positive 8. Now keep in mind, if this were absolute value equals a negative 8, we would have no solution because absolute value cannot be negative. So now we need to think to ourselves, we just have absolute value, and I have, well, what is absolute value? Let's pretend we don't know what's in here. Absolute value of something equals 8. I know it's either 8 or negative 8 because those are both two distances from 0. So my two equations will be m plus 10 equals negative 8, or m plus 10 equals positive 8. And I solve both of those equations. So to get m by itself, I subtract 10. So m equals negative 18. Or the other equation, I subtract 10. And m equals negative 2. Okay, so my two solutions are listed there, negative 18 and negative 2. All right, a word problem. Read through the problem first and let's see if we can understand what it's talking about. An aircraft carrier left Hawaii 1 hour before a fishing boat. The ships traveled in opposite directions. The fishing boat traveled 20 kilometers an hour for 10 hours. After this time, the ships were 530 kilometers apart. What was the aircraft carrier's speed? So maybe we want to draw a picture first of all. So we've got an aircraft carrier leaving Hawaii, and we've got a fishing boat. So I'm just going to draw a picture first of all. All right, now that we've made sense of the problem, and I've got a wonderful artwork here, we can see what's going on. So we've got a boat, an aircraft carrier, there's a jet right there, leaving Hawaii an hour before the fishing boat. The fishing boat's traveling the opposite direction, 20 kilometers an hour for 10 hours, which means the aircraft carrier left an hour earlier. It's been traveling for 11 hours. They're now 530 kilometers apart. So how do we make sense of this problem? Well, their total distance, so I need to add up this distance traveled plus this distance because that'll give us our total of 530. So I know I'm traveling 11 hours at x kilometers per hour with the aircraft carrier plus 20 kilometers an hour times 10 hours for the fishing boat. That equals 530 kilometers total. So I simplify this equation, 11x plus 200 equals 530. And if I subtract 200 from both sides, I'm left with 11x equals 330. And divide both sides by 11, I get x equals 30. So 30 kilometers an hour is how fast that aircraft carrier is traveling. And sure enough, we were correct. Okay, next question. Draw a graph for the inequality. So n is greater than 2. So at 2, I have an empty circle. Because it doesn't include 2, it's not also equal, then we need to figure out which way we're shading. So I can choose test points. I could choose 1. Is 1 greater than 2? No, it's not. So this does not work, which means the other side should work. I could try that. Is 3 greater than 2? Yes, it is. So yes, that's where all the solutions lie. So this shows all of the solution set for all the numbers greater than 2. All right, next one. Write the inequality for this graph. Well, it's an empty circle. The numbers are going less, so it's just going to be a less than. So all my values are less than 0. Remember, if it were filled in, then we would include the also equal to. All right, next one. There we go. So negative 14 is greater or equal to n minus 20. So it's just like solving an equation. You get the n all alone, so we add 20 to both sides. So we're left with 6 greater or equal to n. So since it's also equal to, we'll put a filled in dot. Then we need to choose a test point. Is 6 greater than 7? No, it is not. So 7 is not a solution. Is 6 greater than 5? Yes, it is. So all 5 on down are solutions. All right, next one. Get the x all alone. X minus 2 divided by 2 is less than 8. So the last step was dividing by 2, so we need to multiply both sides by 2. So x minus 2 is less than 16. Now we add 2 to both sides of the equation. X is now less than 18. So it's just less than, so it's going to be an empty circle. And we can choose a test point. Is 17 less than 18? Yes, it is. So that will be the direction of all the solutions. Next one. We need to distribute first of all. So I've got negative 18. Positive 3 times positive n is positive 3n. Less than negative 69. Get the n's all alone, so I add 18 to both sides. That leaves me with 3n is less than, is that 51, a negative 51, and divide both sides by 3. Remember when we divide, nothing happens to the sign. If we were to divide both sides by a negative, we would have to flip our inequality around. But since we're dividing both sides by a positive, it stays as a less than. Negative 51 divided by 18, or 3, rather, is negative 17. So it'll be an empty circle at 17. And choose a test point. Is negative 18 less than negative 17? Yes, it is. So my solutions will go that way. Okay. Question 20, we've got k's on both sides of the equation, so we need to get the k's alone on one side. So before I do that, I'm just going to combine like terms. So I've got negative 3 and negative 6, so I'll combine those. I can't combine anything on the left side, but I'll have 6k, and negative 3 and negative 6 is negative 9. Okay, now I will subtract 6k from both sides. Left with 1k, negative 8 plus 1k, or just k, is greater than negative 9. Don't lose that negative. Then we add 8 to both sides. K greater than negative 1. So it's an empty circle. Choose a test point. Is negative 2 greater than negative 1? No. Is 0 greater than negative 1? Yes. So my solutions lie to the right of negative 1. Okay. Next one here. Same thing. Let's get the n all alone. So let's distribute first. So a negative 6 times a negative 6n is a positive 36n. Negative 6 times a positive 6 is negative 36. And then I've got negative 7 less than 209. So now I can combine like terms. 36n minus 43 when I combine negative 36 and negative 7. Always look for those negatives to the left of the term. And less than 209. Get the n's on one side, so add 43. Once I do that, I have 36n less than, is that 252? And then we divide both sides by 36 to get n all alone. 252 divided by 36 is 7, I believe. So n is less than 7. So when we graph that, we'll have an empty circle at 7. Choose a test point. 6. Is 6 less than 7? Yes. So our solutions will go that way. All right. Next one. Now we have a compound inequality. So in order to solve the compound inequality, we still need to get the x all alone. So here x is multiplied by negative 7, so I need to divide all parts by negative 7. So I'll cancel out, leave an x in the middle. Negative 70 divided by negative 7 is positive 10. And since I'm dividing by a negative, I need to flip my sign around. Negative 56 divided by negative 7 is positive 8. Keep in mind that needs to flip around as well. So 10 is greater than x, greater or equal to 8. I can flip that whole inequality around if I'd like, so that the 8 is at the beginning, but 8 is less or equal to, so we'll put it a filled in dot is less than x, which is less than 10, empty. And the x is in between all those, so we'll just connect the 8 to the 10. Okay, next one. So next we have the OR inequality. So we need to solve both inequalities separately. So v is divided by 5. So I'll multiply both sides by 5 here. So I have v less or equal to negative 5. So that one's finished. Go to the next one. V is divided by 5 again. So multiply both sides by 5. And we get v greater or equal to a positive 5. So we'll graph both separately. V is less or equal to negative 5, filled in, and less than is that way. Or v is greater or equal to 5. Once again, filled in, going that way. Check our answer, and it matches. Next one, absolute value inequalities. So remember with absolute value inequalities, we need to get the absolute value alone. So I know something in here, when I take the absolute value, is greater than 25. So if I'm picturing it in my head, I know it's more than 25 units from 0. So I know it's either at 25 or negative 25. And I know it's more than that distance. So I know the graph is going to look like this. So I take whatever's in there, negative 5p, and I know it will be less than negative 25. So that's the one boundary I found. Or negative 5p, because that's what's inside the absolute value. That expression has to be greater than 25. And then I solve both of those down. So divide by negative 5, and I get p. Remember, I'm dividing both sides by a negative, so that sign flips. Anytime I multiply or divide by a negative, my inequality sign flips. It'll be positive 5. And divide by a negative here. I'm going to flip my sign as well. So p will be less than negative 5. So p is greater than 5, or p is less than negative 5. So those are empty circles. Greater than 5, less than negative 5. It should look like that. Another absolute value inequality. This time we need to get the absolute value alone first. So let's subtract 1. So I have absolute value of x divided by 10 is greater than 1. So now as we picture that, we know it's greater than 1 away from 0. So it's either at 1 or negative 1 that these are at. So I take whatever's in there, x divided by 10 is either less than negative 1 or it's greater than 1. So I set up both inequalities there, and now I need to solve them. So to get x alone, I need to multiply both sides by 10, and I get x is less than negative 11. Actually, it's negative 10, isn't it? Forgot how to multiply. The other one, multiply it by 10, and I get x greater than 10. So if I take a look at both those, x is less than negative 10. It'll be an empty circle. X is greater than 10. Empty. And note is 12. 12 is greater than 10, yes. So I'll go that way. Okay. And let's check the answer. And it matches up. Move on to the next one. Solving the proportion. So remember, proportions is just a fancy equation. So I know 9 divided by 7 equals x divided by 6. So to get x alone, I can multiply both sides by 6. So I'm left with 54 over 7 equals x. What I could do there is I could divide both, since I'm dividing by 7, 54 divided by 7. Do I know what that is? Well, not off the top of my head. It doesn't come out cleanly. I know 7 goes into 49 7 times. 7 times 7 is 49 with 5 left over. So 7 and 5 sevenths, or 54 sevenths, or if you need to change it to a decimal, about 7.71. Okay. Next problem, we still have a proportion. Let's say a similar process. 8 divided by 5 equals the quantity n plus 7 divided by 7. So I can multiply both sides by 7. I get 56 over 5 equals n over 7. Now 56 doesn't divide by 5 into a nice integer. So I'm going to multiply both sides by 5. It's easier to multiply. Now keep in mind this was the quantity n plus 7, so I'll put that back in parentheses. So I have 56 equal to, now I can distribute this 5n plus 35. Now if I want to get the n by itself, I can subtract 35. And that'll leave me with, what is that, 21 equals 5n. And then to get n by itself, I can divide by 5. So that doesn't divide into a nice easy integer, but we can leave it as 21 fifths, or 5 goes into 21 4 times, with 1 remaining. So 4 and 1/5, or if you prefer decimal, 4.2. Okay, in this proportion we have the variable occurring twice. So nothing really changes. 6 is divided by 7 is equal to p divided by the quantity p minus 6. So in order to solve this equation, I can multiply both sides by p minus 6 to get that p minus 6 out of the denominator there. So remember, it's in the denominator, so it is a quantity. So I can distribute that. 6 times p, and 6 times negative 6 is negative 36. Over 7 still on the left side, and we just have p on the right side. So now this 7 doesn't divide evenly, so we can multiply both sides by 7. So I have 6p minus 36 equals 7p. If I rearrange, get the p's on one side, subtract 6p. I'm left with a negative 36. Don't lose that negative. Equals 7p minus 6p is 1p, or just p. So p would equal negative 36. Another proportion, the ends are over here. So now another thing to keep in mind is we've seen how that works when we're solving those proportions. Another thing to remember is that we end up multiplying the cross products together. So since I'm dividing by n minus 5, I'm going to multiply both sides by n minus 5. And that's going to end up multiplying by the numerator on the opposite side. And since I'm dividing by 5 over here, I can multiply by 5 to cancel it out. I end up multiplying by 5 on the numerator on the opposite side. So really these cross products get multiplied together and these get multiplied together. So if you end up doing that in one step, that is fine as well. So then we distribute 5n plus 45. And on the right side we'll have 10n minus 50. Get the n's together on one side, so I'm going to subtract 5n, which leaves me with 5n minus 50. And on the left side I just have a positive 45. So I am going to add 50 to both sides. When I add 50, that gives me 95 equal to 5n. And then it's a matter of dividing by 5. And that'll give me 19 equals n. So if we check that over, n is 19. Next, take a look at graphs. Find the slope. Remember, slope is our variable m, and that's rise over run. And slope can be also quantified as the difference of the y and the difference of the x. So if you subtract the y's, subtract the difference of the x's. So find the slope. So we find out what's the difference in the y values. Or y's go up and down. So I count 1, 2, 3, 4. It's going down. So it's good to check the line. It's a negative. So this is going down 4. And then it goes over 1, 2, 3 units. So it's rise. It drops. It's negative. So negative 4 over 3. That can't be simplified. So we could just leave it like that. Next, find the slope this time. So if you wanted, you could make a graph like we had in the previous problem. But if you don't want to make the graph, remember we can just think of slope as our difference of our y values and the difference of the x. Divide the two, then reduce. Then you got slope. So if I find my y values, negative 4 and 4, I'll subtract those, and I'll subtract those x values on the bottom. So negative 4 minus negative 16. Okay, so if I find the difference of the y's, that gives me a negative 8. And negative 4 minus a negative 16 is really adding. So negative 4 plus a positive 16 is positive 12. And then I can reduce. 8 and 12 are both divisible by 4. So negative 2 over 3 would be my slope in simplest form. Check my answer, and I'm correct. Good. Next one. Slope of this line. Remember, if it's in slope-intercept form, it's pretty simple to find out what the slope is. Is this in slope-intercept form? Is the y by itself? If so, m stands for slope. Remember, m is the coefficient of x. B stands for the y-intercept. Okay, so we just take a look at this. What's the coefficient of x? 2. So our slope is 2 in this case. All right. Slope of a line parallel. Remember, parallel lines have the same slope. This one is in slope-intercept form, so its slope is negative 4/3. So slope of a line parallel would be the exact same. It would also be negative 4/3. Now we want a graph. So remember, this is in standard form. Negative, or 3x minus 4y equals negative 8. So this equation would be in standard form. Standard form, there's two different ways we can graph these. I'll show you both those methods, and you can determine which you want to choose. There's actually 3 different methods that we've talked about. One is creating a table, one is using slope-intercept, and one is finding the intercepts from standard form. So let's talk about how we find the intercepts first of all. Okay, so I can create a table. I know my x-intercept, my y is 0, and my y-intercept, my x-coordinate is 0. So if I plug 0 into those and solve for the other variable, I can find my intercepts. So if I put 0 in for y, I have 3x minus nothing equals negative 8. So it's really 3x equals negative 8. Divide by 3, x equals negative 8/3, which is negative 2 2/3 when I simplify it into a mixed number. We can do the same thing, put 0 in for x. So 3 times 0 is 0. Minus 4y equals negative 8. So it's really negative 4y equals negative 8. And I can divide both sides by negative 4. And we get y equal to 2. So when x is 0, y is 2. So I can graph both those points. So negative 2 2/3, 0. So negative 2 2/3, up 0. And over 0, up 2. And then I connect the dots, and that is the graph, or the line of that equation. Okay, so that's by finding the intercepts. I can do the same thing. I'll do it in a different color here. or graph the same equation by taking this equation and converting it into slope-intercept form. So I start with 3x minus 4y equals negative 8. Slope-intercept form, I'm solving for y. So I'll subtract 3x. So I'm left with negative 4y. And I can't combine negative 8 and negative 3x. So I'll just put the negative 3x first, the negative 8 second, because I like to have the x variable first. And to get y by itself, we divide by negative 4. So in this case, we have y equal to negative 3 divided by negative 4 is positive 3/4 x. Negative 8 divided by negative 4 is positive 2. Remember, in slope-intercept form, the y-intercept is the number by itself, the b, which is at 2. Slope is coefficient of x, 3/4. So I go up 3 over 4 from that point. And notice if I connect those, it's on the same line. Okay? And if you've forgotten how to do all that, final way you could graph and would be by creating a table. So once I get it into slope-intercept form, I could just plug in an x and a y. Plug in any x and y if x is that I want. 0, 1, 2, those are small numbers. They're easy to work with. Substitute 3/4 times 0 is 0, plus 2 is 2. Put in 1. 1 times 3/4 is 3/4, plus 2 is 2 and 3/4. 2 for x, 2 times 3/4 is 1.5, plus 2 is 3.5. That gives me some points that I can plot on my graph. So 0, 2. Common point. We've used it for all the other ones. 1, 2 3/4, and 2, 3.5. Notice that would give me the exact same line as well. So I can create a table once I get the equation solved for y. The other method was to get it in slope-intercept form. Get the y by itself. And the other was finding the intercepts. So you just choose whatever method you're more comfortable with and graph it whichever way you want. Now let's double check to make sure we did that right. Yes, perfect. All right, next one. This one I would recommend is in slope-intercept form. So let's see if we can zoom out here, get the full graph. Okay, so this one's slope-intercept form. Y equals mx plus b. Remember the intercept, and y is by itself. B is our intercept, so our intercept is negative 5. And our slope is the coefficient of x, that's negative 3/4. So I go down 3. And we run out of graph here, so we can kind of just estimate 1, 2, 3, 1, 2, 3, 4 over 4. The other thing that you can do if you want to actually count points, instead of going down 3, we can go up 3. 1, 2, 3, and go backwards 4. Either way would put us on the same line. You just got to do a better job of connecting the dots. Okay, next one. 1 equals negative y. Well, this one doesn't have an x, but we do need to solve for y. So we divide by negative 1, and we get negative 1 equals y. In this case, since it's in slope-intercept form, by itself is the intercept negative 1. And what's our slope? Well, if I were to rewrite it, we don't have any x's, so we have 0 x's. Our slope would be 0. So it's not moving up or down at all. And as always, if I forgot how to do that, I can take a look at, find my intercepts. Y is negative 1. Well, there's no x, so it doesn't hit the x-axis. So I would draw a line that's parallel to the x-axis. And the other thing I can do is I can create a table. I know that y is always negative 1. So I could put various x values in and plot those points. 0, -1, 1, -1, 2, -1. And see that that's a horizontal line going through the y-axis at -1. Remember, when it's x equals, let's say this were, let's put a different color on here. I don't think there's an example on our review. Let's say it were x equals 2. Well, in that case, x would always be 2. The x-intercept is 2. There's no y-intercept, so it would be parallel to the y-axis. So that'd be a vertical line. X is 2 always. I could choose random y variables. 2, 0, 2, 1, 2, 2. Okay? All right. Next one. Let's say our x-intercept is -3 and our y-intercept is -1. So let's just plot those on here. X-intercept means across the x-axis at -3. Y-intercept means across the y-axis at -1. Those are 2 points for our equation. We can take a look at those and see how the line goes. My line's not very straight, but you get the idea. Write the slope-intercept form of this equation. Remember, slope-intercept form, y equals mx plus b. At this point in the semester, you should have a good handle on that. So, y equals, let's start with our intercept. What's our intercept? Where does it cross? It's at 3. And what's our slope? I'll find another place where it crosses evenly. How about here? So it goes up 1 over 1, 2, 3, 4, 5. So our slope would be 1/5. So our slope is 1/5, and our intercept is 3. So y equals mx plus b. Since it's a positive intercept, it's plus. For a negative intercept, it would be minus. Slope intercept of this one. It's already written out for us. So y equals m x plus b. So -3x plus 0. I don't need to write the plus 0. I can save myself some ink or pencil lead. Slope-intercept form. So this one is in standard form. X's and the y's are on the same side of the equation. So in order to get the y by itself, I can subtract x first. I'm left with 6y. And I can't combine these, so I'll put the -x first, -48 second. Then divide by 6. Divide everything by 6. Left with y equals -1x over 6. And -48 divided by 6 is -8. So y is all alone, so it's now in slope-intercept form. Okay, you can see we have the same thing that the answer key has. Next, we're going to write the slope-intercept form through the given point. So this line goes through -2, -2, and its slope is 3/2. Well, I can start off in slope-intercept form, and I can plug in what I know. I know the slope, the m, is 3/2. So I can say y equals 3/2 x plus b. What else do I know? It goes through this point. I know this is an x and this is a y coordinate. So I can plug in my x and my y. Y is -2. 3/2 times x is -2. Oops, not very good too. And then we add b. We don't know what b is yet. So solve for b now. So -2 equals, well, -2 times 3 is -6. Divided by 2 is -3. Plus b. Get b all alone, so I add 3. So b is 1. So I rewrite my equation. Y equals m, we said was 3/2. X plus b. B we said was 1. So 3/2 x plus 1 would get me an equation there. Okay. the other way we could do that, I showed you how to use point slope form. So point slope form, y minus y1 equals m x minus x1. So if you're not given the intercept this way, you can start off with that. So I can take one of my y coordinates, so y minus, in this case the y coordinate is -2, equals m 3/2. So you can decide which method is easier. X minus x1, my x here is -2. Okay, so then we just simplify this one down. So y plus 2 equals, I can distribute 3/2 x, and this is really plus 2. So it would be plus 3, because 2 times 3 is 6, divided by 2 is 3. And then to get the y all alone, to get it in slope-intercept, I would subtract 2. So I'd have y equals 3/2 x plus 1. It agrees with what I had in the bottom, and it agrees also with the answer. So just keep in mind this one is the point slope. Remember. So point slope form is the third form of the equation that we've talked about. All right, next one. Slope-intercept form goes through 2 points. So remember the key thing we got to find, we always got to find a slope. We always got to find the y-intercept. So in order to find the slope, you got to find the difference of the y and the difference of the x. Divide the two, then reduce, and you got slope. So in order to find my slope here, I'm going to take my y values, -1, -5, and subtract the x values on the bottom, -2 minus 0. And that's going to give me -6 over -2. Divide the 2 and reduce, and I've got 3. So my slope is 3. Just got to find my y-intercept. My y-intercept is when x is 0, so actually I don't need to do much work here. My y-intercept is 5. So I can rewrite my equation y equals 3x plus 5. And keep in mind, if I wasn't given my y-intercept, I could still find it by the process we did in the previous problem. So just plug in one of these points in my x and y, solve for b. All right, so let's find this equation. It goes through 3, and it's parallel to y equals x minus 4. Keep in mind, two things we got to find are slope and intercept. In this equation, this slope is 1. It's 1x. Parallel lines have the exact same slope. So if it has the same slope, I know my line will have a slope of 1 as well. Okay, so next we need to find our intercept. We're not given it this time, so we need to start with our equation. I'm going to start with y equals 1x plus b, because I know my slope but not my intercept. I'm going to plug in my points. 3 is y, x is 3 as well. So once I do that, 3 equals 3 plus b. Subtract 3 from both sides, get b all alone. Those cancel out, and I get nothing left. So nothing is b. My b is nothing. So y equals 1x plus nothing, or just 1x. Perpendicular. So if the line goes through -2, -2, and it's perpendicular. Perpendicular means it's opposite reciprocal for the slope. So opposite reciprocal. Let's see if we can spell. So if this slope is -2/5, the line perpendicular slope would be opposite, positive, reciprocal. Flip it around, 5/2. Not giving us an intercept, so I'll plug values in and go from there. So y equals 5/2 x plus b. And I'll plug in my x and my y. Y is -2. X is -2. and solve for b. So negative 2 times 5 is negative 10, divided by 2 is negative 5, plus b. That equals negative 2. Add 5 to both sides, you get b all alone, and I get 3 is b. So if my b is 3, y equals mx plus b, 5 halves x plus 3. And yes, another winner. All right, next one. Write the standard form of the equation. Well, standard form is ax plus by equals c. So we want to get the x's and the y's on the same side of the equation. So here I just need to subtract 2/3 x to get it all alone. Do it to one side, do the same thing to the other. So I'll keep the x term first, so negative 2/3 x. It's a positive y. And that equals, we just have a 1 left over. Okay, so this would be acceptable. Typical times that we want to get rid of the fractions. So in order to do that, it's all divisible by 3, or this fraction is divisible by 3. So if we multiply everything by 3 on both sides of the equation, we keep the equation the same, it just eliminates those pesky fractions. So the answer key is going to show a fraction, or a fraction eliminated. So 3 times negative 2/3 is negative 2x. 3 times y is 3y. 1 times 3 is 3. So, as I mentioned, our answer key shows it in this one, except why is it negative? Oh, I see why. So, the other thing that oftentimes when we write equations, we don't want fractions and we don't want negatives at the beginning. So what they did is multiplied everything by a negative as well. So it'll be a positive 2x and a negative 3y and a negative 3. So this is how they have it. I would accept either the previous ones. If you just want to keep it like that, that's fine. It just makes it easier to work with when it comes to graphing and so on. So standard form once again, let's distribute y minus 3 equals 3/4 x minus 3 times 4 is 12, negative 12, divided by 4 is negative 3. And let's get the x terms alone on one side, so minus 3, 4, or x and y terms alone on one side. Subtract that 3/4 x. So we're left with negative 3/4 x, positive y, and negative 3 equals negative 3. And let's get our constant terms on the other side. Notice when we do that, that eliminates all our constant terms. So we have negative 3/4 x plus y equals nothing. So I could leave it like that, or in order to eliminate the negative and the fraction here, let's multiply everything by negative 4. Distributes, that'll give us 3x. And this will give us negative 4y. And we still have a 0 on the right side of the equation. As I mentioned, I would accept either form of the equation. All right, simplifying radicals now. So when we do that, remember we want to break these apart. So 147, we want to think of perfect squares that we can break it into. So when I think of 147, I got to think of perfect squares I can divide. So 147 can be divided by 49. It's 49 times 3. So square root of 49 times square root of 3. And then I can break variables into groups of squareds. So I've got an r squared and an r squared. And then we just simplify as much as we can. So we've broken this apart. Square root of 49 is a perfect square, which is 7. Square root of 3 I can't break down any further. Square root of r squared, well, the radical and the square cancel each other out. And same here, times r again. And we put everything that's not under the radical first, so 7 times r is 7r squared. And times the square root of 3. We can just rearrange all those factors around. Okay, so the key thing is look for perfect squares that we can eliminate as we go through it. Okay. Next one, when we're adding radicals, we need to look for common radicals, like radicals. So 2 squared root of 5 plus 3 times the square root of 45 minus 2 times the square root of 24. None of these have like radicals. So let's see if we can simplify any of them down. 2 square root of 5. Square root of 5 is as simple as it can go, so we'll leave that one. Plus 3 times square root of 45, I can break into 9 times 5. So square root of 9 times square root of 5. And minus 2 times square root of 24. 24, if I think of perfect squares, 24 is 8 times 3. Neither of those is perfect. 12 times 2, neither of those is. 6 and 4, 4 is, so let's break it into those. Anytime I can break it into perfect squares, it makes it easier to simplify. So this first term, 2 square root of 5, we'll keep as 2 square roots of 5. And the next term, 3 times square root of 9 times square root of 5. Well, square root of 9 is 3, so we have 3 times square root of 5. Next term, negative 2 times square root of 6 times 4, or square root of 4. Square root of 4 is 2. So now we simplify all these. 2 times the square root of 5. 3 times 3 I can multiply times square root of 5, so that's going to be positive 9 times square root of 5. The final term, negative 2 times 2, I can multiply those together to give me negative 4. And the 6 stays under the radical. So I need to see which ones I can combine. These two terms have like radicals. 2 square roots of 5 plus 9 square roots of 5 is 11 square roots of 5. And we subtract 4 square root of 6. They're not like radicals, so we cannot combine them. Okay, and looks like it matches up. Next one, multiplying. So it's just distributive property again. So 4 times square root of 15 times 5 is 20 square root of 15. 4 square root of 15 times negative 5 square root of 10. 4 times negative 5 is negative 20. And 15 square root of 15 times square root of 10 is square root of 150. So now we see if we can simplify these down at all. 15. Oops. Let me hide that answer. Let's see. So 15, we can't break that down any further. It's 5 and 3. Square root of 5 and square root of 3 aren't perfect squares, so we can just leave that as 20 times the square root of 15. And we have negative 20 and square root of 150. 150 break into 25 times 6. And 25 is a perfect square, so we can simplify that down even further. So 20 times square root of 15 minus 20 times square root of 25 is 5. Square root of 6. And negative 20 times 5 is negative 100. So we have negative 100 times square root of 6. And neither of those are like radicals, so we can't combine those any further. And it matches up with what we have up there. All right, and the last one for algebra deals with sequences. So first of all, we need to determine if this is an arithmetic sequence. If so, find the common difference and the term and explicit recursive, the next 3 terms. So I can see that these are going down 10. So that's going to make it arithmetic. Has a common difference. I'm either adding or subtracting a common difference. So the next one would be negative 43, negative 53, negative 63. That's the next three terms. Common difference, that's negative 10. The term named in the problem, well, we need to come up with that by creating an equation. So explicit and recursive. Let's start with recursive. That's probably the easier one to form. And that one helps us get the next three terms. What am I doing each time? I'm subtracting 10. So the nth term is equal to the previous term minus 10. I'm just subtracting 10 every time. Explicit, that one, the nth term, is equal to, well, my first term plus n minus 1 times my common difference. So my nth term will be equal to my first term, which is negative 3, plus n minus 1 times my difference. My difference is negative 10. So now if I want to find the 40th term, I'll just say the 40th term is equal to the first term plus n minus 1, so 39, times negative 10. So the 40th term should be equal to negative 3 plus 39 times negative 10 is negative 390. Negative 3 minus 390 is negative 393. And if we check all those, common difference negative 10, next three terms, explicit formula we had, and recursive. All right, so that signals the end of algebra. The next few problems we'll take a look at the accelerated extra problems that the accelerated students will be working on for the semester review. Okay, got my new helper now. So we're going to get started showing you how to graph this inequality. So if you've forgotten how to do that, keep in mind this is in slope-intercept form, so we can graph the line. Intercept is 5. Slope is negative 1/2, so down 1/2. Next thing for a dividing line, since it's less or equal to, since it's also equal, it includes everything on there, so we'll draw a solid line. Or just less or greater, it'd be a dashed line. So how to figure out what side the solutions are, we choose a test point. I'm going to choose 0, 0. Put 0 in for y, 0 in for x. It's going to give me 0 plus 5 is 0 less or equal to 5. Well, 0 is less than 5, so all our solutions will be on this side. Okay, perfect. All right, next one. Solve the system by graphing. So we need to graph both equations and find out where they cross. They're both in slope-intercept form. This one, the intercept is negative 4. Slope of 4, 1, 2, 3, 4 over 1. Okay, we play connect the dots. And somewhat good line. And then we graph the other one. That one in red. So intercept of 3, slope of 1/2, up 1/2. We find ourselves a crossing point, don't we? This intersection here is at 2, 4. So 2, 4 will be our solution. Perfect. Give me a high five. Yes. All right, next one. Solve by substitution. Remember, substitution, we want to get the x or the y alone. And in the first case, this equation here has the easiest one to do because the y has a coefficient of 1. So if we just subtract 7x from both sides, we've got y equals negative 7x plus 12. And the other equation, we have negative 4x minus 2y equals negative 4. So I know I want to substitute out negative 4. Or y, rather, sorry. So y is the same as negative 7x plus 12. So if I take out y and I substitute negative 7x plus 12, that should equal negative 4. So distribute negative 4x. Negative 2 times negative 7x is positive 14x. And negative 2 times positive 12 is negative 24. That equals negative 4. Combine like terms, so I've got 10x minus 24 equals negative 4. And then add 24 to both sides. Gives me 10x. Uh-oh, am I boring you? 10x equals 20. And divide both by 10. X equals 2. Now that we know what x is, we need to plug it back in and find what y is. So here I can find y. Y is negative 7 times x. X we said was 2 plus 12. So y equals negative 14 plus 12. And negative 14 plus 12 is negative 2. So x is 2, y is negative 2, so that is my ordered pair 2, negative 2. And yes, that is the answer. Wonderful. All right, next one. We're going to solve this one by elimination. Remember, elimination, we want to get rid of the x or the y term by either adding or subtracting. Notice 8x and negative 8x are opposites. 7y and negative 3y are not the same. So I can add both equations because that will cancel out 8x plus negative 8x is nothing. 7y plus negative 3y is 4y. Negative 28 plus 12 is negative 16, right? Okay. So then we divide by 4. Y equals negative 4. Y is negative 4. We've got to find what x is. So pick an equation. It doesn't matter. I'll choose the top one. 8x plus 7 times y. Y is negative 4 equals negative 28. So 8x minus 28 equals negative 28. Get the x alone, so I'm going to add 28 to both sides. And that's going to cancel out over here, so 8x equals nothing. And if I divide by 8, I get x equals nothing as well. So 0, and my y is negative 4. And yes. Okay, next one. I want to solve this one by elimination. Notice negative 10x, negative 7x are different. 9y and 2y are different. So we're going to need to multiply the equation first before we can figure out how to eliminate. So I'm going to multiply. I want to eliminate my y's. So I'm going to multiply this equation by 2 and this one by 9. That way the y's will be the same. So 2 times negative 10x is negative 20x. 2 times 9y is 18y. And 2 times negative 1 is negative 2. Keep in mind we have to multiply everything, otherwise we change the whole equation. And keep the equation equivalent if we multiply everything. So 9 times negative 7 is negative 63x. 9 times 2y is 18y. And 9 times negative 5 is negative 45. Okay, now what do we have to do? Well, the y's are the same, so we can subtract them. Subtract these two equations. Negative 20 minus a negative 63 is a positive 43x. 18 minus 18y cancels out. Negative 2 minus a negative 45 gives us a positive 43. Divide both sides by 43. Yep. We get x equals 1. X is 1. What do we have to do? We got to find y, don't we? So plug into any of these equations. I'm going to choose this one. Negative 7 times x is 1 plus 2y equals negative 5. So negative 7 plus 2y equals negative 5. Get the y by itself. We need to add 7, don't we? So we're left with 2y equals 2. Divide by 2. Y is also 1. So x is 1, y is 1. That's our ordered pair. Let's check it to see if we did it right. There we go. All right, next one. Let's sketch the system of inequalities. So let's graph both of those. The first one, x less than 2. Remember that goes through the x-axis at 2. It's a vertical line. Remember it's dashed because it's less than, not or equal to. Okay. Remember that one would shade. You could choose a test point. 0, 0. Is 0 less than 2? Yes, it sure is. So I'm going to end up shading this way. Then the next one, y is greater than x plus 1, intercept of 1, slope of 1. That also is a dashed line. And we can choose a test point of 0, 0. Is 0 less than 0 plus 1? Or greater than, actually. Is 0 greater than 1? Is 0 greater than 1? No, it's not. It is not, so it's not a solution. So the opposite side will get shaded. Okay? And so then we find our solutions where those overlap. And yep, they overlap right here in this region up here. Okay? There we go. And I believe this is the final problem. All right, a word problem. Finish it up. Mike selling tickets to Spring Musical. On the first day of ticket sales, school sold 10 senior citizen tickets, 6 child tickets for a total of $156. School took in $144 in the second day by selling 11 senior citizen tickets and 2 child tickets. Price of a senior citizen ticket and a child ticket. So let's say senior citizen ticket is X, child ticket is Y. Here's our first scenario. 10 X's, 10 senior citizens, plus 6 children equals a total of 156. Next scenario, $144 on 11 seniors and 2 children. So 11x plus 2y equals 144. Now it's just a matter of solving the system of equations. So I notice the x and the y's are different, but if I multiply this one by 3, it'd be 6y. So I will have 33x plus 6y equal to 144 times 3. Oh, what is that? 450, 18, 4, 32. Okay, and the original one was 10x. Are you done? You don't want to sit here anymore? Equals 156. All right, you can be done. I gotta finish this one. Okay, so now we need to determine whether we need to add or subtract to get the x and the y's alone. So I need to eliminate these y's, so I'm going to subtract the two equations. And in doing so, I'll have 10 minus 33 is negative 23x. 6y minus 6y cancels out. 156 minus 432. Ooh, gonna make me do some math now. Let's see here. What is that going to be? It'll be negative 276. I divide that by negative 23. When I divide that by negative 23, I get 12. So x is 12. Plug that into one of my equations. So 10 times x, 10 times 12, plus 6y equals 156. So 120 plus 6y equals 156. Okay, subtract 120. And I get 6y equals 36. Divided by 6y is 6. Okay, so the price of a senior citizen ticket is $12. And a child ticket is, let's say, $6. So we check our answer. It appears to be correct. So that comes to the end of our review. Feel free to go back and check over any if you need help. Otherwise, I can help you in class, or send me an email or a note on Google Classroom, and I can help you out in anything that you need. So have fun reviewing for the exam.